morning children, welcome back to Maths class. Today we are going to start a new chapter, surface areas and volumes. All of you are familiar with this chapter and formulas of surface areas and volumes of solid figures. So let us revise. The first one is cube. So to find the surface area of a cube, how many surfaces are there? There are 6 surfaces for a cube. 1, 2, 3, 4, 5, 6. For a cube, all the faces or all the surfaces are having equal area. What is the shape of each surface? It is a square. Now, there are 2 types of surface area. One is curved surface area or lateral surface area and total surface area. So, first we will see what is the curved surface area of a cube. CSA of a cube. So, first we will start with cube. CSA of a cube. CSA equals, to find the lateral surface area or the curved surface area, we know that there are 4 lateral surfaces or curved surfaces. These side surfaces are called curved surfaces. So we know, as we know, all the surfaces are in the shape of a square. We know area of a square is a square. So to find the lateral surface area or the curved surface area of a cube, first we will see what is the area of one face. Area of a cube is a square, that is side into side a square. So there are 4 lateral surface or curved surface. So lateral surface area of a cube is 4a square. 4a square, square units we will write as, if it is centimeter, when you do the sums, it is centimeter square. If it is meter, we can write meter square. So as we have 4 curved surface or lateral surface, area of a square is a square, therefore CSA is equal to 4a square. Now we will see what is total surface area. Total surface area means area of all the 6 surfaces. All the 6 surfaces are square in shape. So there are 6 surfaces, therefore total surface area is equal to 6a square. Square units. So CSA or lateral surface, short form of curved surface area is CSA. CSA or lateral surface area of a cube is 4a square, as we have 4 squares, and total surface area, there are 6 surfaces, so 6a square. Now, what is the volume of a cube? So we know that volume means, what is the meaning of volume? The capacity it can hold or quantity we can keep it inside. So when you open this cube, if we keep something inside, how much we can keep? The quantity is called volume. So if you wanted to keep something, suppose if I pour some sand inside, we can pour the sand and the sand will be on the base part. So, and till the height, how much height for this cube? Till that we can fill this cube. So, to find the volume of a cube, the basic formula is area of the base into height. So, how much area is having for this base, that there we can keep the thing or the object. Till the height we can keep, till here we can keep, right? Therefore, volume of any solid figure is, the basic formula is volume equals area of the base into height. Area of the base into height. So here volume, when we write, this is the base, shape of the base is square. We know that area of the square is a square till the height. So height means edge or the side of the square, that is again a, all the sides we considered as a. Therefore a square into a, it will become a cube. A square is the area of the base as it is a square. Edge of the square is again a, so a square into a. Volume is a cube, as we have 3 measurements. Cubic units is the unit. Cubic units. So that's about cube. Now we will see a cuboid. Cuboid. So here is a cuboid. So even for cuboid also there are 6 surfaces. Now we will see cuboid. If you keep the cuboid like this as it is, we can consider this as the length, this as the breadth and this is the height of the cuboid. So as length, breadth and height. So now first we will see the lateral surface area or curved surface area of a cuboid. So to find the curved surface area of a cuboid, curved surfaces, how many curved surfaces are there? We have 4 surfaces. Side surfaces are 4 surfaces are there. In that, this surface and this surface are identical, same, and these 2 surfaces are same. So to find the curved surface area, we will find out area of this 4 surface and we will add it. So once if you find the area of this surface, that will be multiplied by 2 or double we will do, that is the 2 surface we will get. Again we will find the surface area of these 2 surfaces. So let us see the surface area of this face. So as I told you, if we consider this is length, this is breadth and this is height. For this is a rectangle in shape. The surface is a rectangle. Area of a rectangle is length into breadth. So here this is the length, but for a cuboid this is the height. So area of this surface, instead of L into B, we will say L into H. Why we use the letter H? Because for a cuboid this is the height. So this surface area is L into H. The same way this surface also area is L into H. So 2 times L into H we got. 2LH we got. Plus, now we want to find the surface area of these 2 surfaces. Now as I told you, this is the breadth and this is the height. It's a rectangle. So area is length into breadth. This we will consider as length. This is breadth, means this is base and height for a cuboid. B into H. So there are 2BH. This side and this side. So plus 2BH. So curved surface area of a cuboid is 2LH plus 2BH. We can take 2H common we can write and L plus B. So curved surface area of any cuboid is 2H into L plus B. Now we will find the total surface area. To find the total surface area, we have to add this CSA plus area of these 2 surfaces. So we have already 2LH plus 2BH is there. Now we will add the area of these 2 surfaces. That is, one is base and one is top. As I told you, this is the length and this is the breadth. This is a rectangle in shape. So area of the rectangle is length into breadth. So here L into B and here also L into B. 2 times L into B. So total surface area 2LB also we will add. So 2LH plus 2BH plus 2LB. So I will arrange it and I will take 2 common. First I will write LB, then BH and then LH I will write. So this is the total surface area of a cuboid, square unit. Square unit. So CSA of a cuboid is 2H into L plus B. TSA is 2 into LB plus BH plus LH. Now the volume. As I told you, volume is area of the base into height. So area of the base is a rectangle. Area of a rectangle is LB and till the height. H is the height. So volume of a cuboid is LBH cubic units. So cuboid CSA is 2H into L plus B. TSA is 2 into LB plus BH plus LH and volume is LBH. Now we will see the next cylinder. So this is a cylinder. Right circular cylinder. Right circular cylinder means the height will be perpendicular to the base. So you are studying only about right circular cylinders. So for a right circular cylinder, there are 3 surfaces. One is the curved surface and 2 flat surfaces. This is base and this is top. So this is the curved surface. So first we will find out the curved surface area of the cylinder. And we have one base and top. They are circular in shape. So all the cylinders which you are learning about right circular cylinders, height should be perpendicular to the base. So now to find the CSA of a cylinder, say I have taken a sheet of paper. See, this is rectangle in shape. If I fold this paper, if I roll it like this, we will get the shape of a cylinder. This is a hollow cylinder. Hollow cylinder means both the side will be opened. This is a closed cylinder. Both the side will be closed. So in this hollow cylinder, this is a rectangular sheet. When I roll it or fold it, I got the shape of a cylinder. So this is the curved surface of a cylinder. So now we will see what is the CSA of a cylinder. So to find the CSA of a cylinder, we know that area of a rectangle. This is a rectangle sheet. This is the length and this is the breadth. Area of a rectangle equals length into breadth. Area of a rectangle is length into breadth. So when I roll it, the length of the rectangle will become this is the shape we are getting. What is this? This is the circumference of a circle. Circumference of a circle is 2 pi r. Circumference is total length of the circle. So length of the rectangle becomes circumference of a circle, and we know that circumference of a circle is 2 pi r. So L become length of the circle become 2 pi r, and the breadth of the rectangle, when we roll it, it will become the height of the cylinder. So 2 pi r into h. So CSA of a cylinder is 2 pi r h. So 2 pi r h, how we are getting is, as it is a rectangle, when we fold it, length becomes the circumference of the circle and breadth becomes the height of the cylinder. Therefore, length 2 pi r, breadth h, 2 pi r into h, 2 pi r h square units. This is the curved surface area of a cylinder. To find the total surface area of a cylinder, total surface area of a cylinder equals curved surface area plus area of these two circular surface. We know that this is a circle. Area of a circle is pi r square. Here one more area is there. So 2 pi r square. So 2 pi r square. Area of two circular surface. CSA is 2 pi r h plus 2 pi r square. This is the formula to find TSA. So here we can take common 2 pi r, we can take common. Here the remaining letter is h and here the remaining letter is r. 2 pi r into h plus r, or you can write 2 pi r into r plus h. Easy to say, 2 pi r into r plus h square units. This is the TSA of a cylinder. Suppose if the cylinder is opened on the top part is opened, then how to find out the total surface area is 2 pi r h plus 1 pi r square, because if it is closed only, we will consider it the area. Then only we can calculate the area. So suppose if in any question, if one side is opened, if the question is, you don't write this formula, we have to write 2 pi r h plus 1 pi r square, which side is closed. 1 pi r square we have to write. Next is volume. Volume of a cylinder. Volume of a cylinder, as I told you, area of the base into height. The base is in the shape of a circle. So area of a circle is pi r square, and height of a cylinder we will consider it as h. So pi r square h is the volume of a cylinder. Cubic units. So CSA of a cylinder is 2 pi r h. TSA is 2 pi r into r plus h. If it is a closed cylinder, then we can use this formula. Otherwise, according to the question, we can change. Volume is pi r square h cubic units. Now we will see a cone. Next is about a cone. So see, this is a cone. It has two surfaces. Cylinder has three surfaces, one curved surface and two circular surface. For a cone, there are two surfaces. One is the curved surface and one is the flat circular surface. So here, how to find out the CSA of the cone? Before that, see cone. See, this is the circular surface. We know that this is the center of the circular surface. If you draw a line from the center, then that is the radius of the cone. So here, So now for this cone, this is a vertex. From the vertex, if you find the perpendicular distance to the center, that is, if you keep a nail or something inside from here to here, what is the perpendicular distance we are getting? That is the height of the cone. So height of the cone is the perpendicular distance from the vertex to the center of the circular base. So this is the height of the cone. From the top vertex to the center of the circular base, what perpendicular distance is there? That is the height of the cone. The distance from the vertex to the circumference, anywhere on the circumference. That is, if I write a letter here, A, B, C and here O, AC is the slant height of the cone. Slant height is the distance from the vertex to anywhere on the circumference. If I draw a line from the vertex to this circumference here, this is called slant height. So AC is the slant height and AO is the height. So I think you understood the difference, and always slant height will be more than the height. And if you join O and C, that is the radius. BC is the diameter of the circular part. If this is the circle, if you draw a big line from one end to the other end, it is the diameter. From center, if you draw a line, that is the radius. So here OC is the radius, BC is the diameter of the circular surface. From the vertex to the center of the circular surface, if you draw a perpendicular line, that is the height. And if from the vertex to anywhere on the circumference, if you draw a line, that is the slant height. So slant height will be always greater than the height. So here, when this is the perpendicular height, we can write angle O is 90 degree. If you apply Pythagoras theorem in this triangle AOC, in triangle AOC, angle O is 90 degree. Therefore, AC is the hypotenuse. AC is considered as the slant height denoted by the letter L, small letter L. OC is the radius. So, AC square is equal to AO square plus OC square. AC square is L square. AO is H square plus R square. So, there is a relation between slant height and radius for a cone. Slant height square will be equal to height square plus radius square. Therefore, L equals square root of H square plus R square, or R square plus H square is the formula to find slant height. If in any question height and radius is given, and if you want to find out slant height, you can use this formula. In the same way, we can use to find H, we can use the formula square root of L square minus R square, and for R, square root of L square minus H square. So L is the greater value, so L is square root of R square plus H square. If you want to find other letters H or R, that is square root of L square minus the other square. So slant height is the larger value than height and radius. So here, how to find out? Now we will see how to find out the CSA of a cone. CSA means this is the curved surface. Suppose if I divide this into, if I draw many lines in this diagram, each one will be in the shape of a triangle we will get. See, when we draw one different lines, and if you divide this curved surface into different parts, each part will be in the shape of a triangle. So you know that area of a triangle is half BH. This base, this is the base, first base, the next part base 2, B1, B2, B3, etc. if you take. And if total area, if you find out, total area will be half into, first triangle base we will consider as B1, and height will be the slant height. Slant height is the line starting from the vertex to the circumference of the circular base. So half into B1 into L plus second triangle if you consider half B2 into L plus etc. If there are 10 triangles here, half into B10 into L we will get. So in all these terms, half L is common. We will take half L into B1 plus B2 plus B3 plus etc. If you write B10, all these bases, half into L into this B1, B2, B3, before all together, it will become the circumference of this circle. And we know that circumference of a circle is 2 pi r, half L into 2 pi r 2 and 2 will cancel. Pi into R into L, pi RL, and this is the CSA of a cone. So CSA of a cone is pi RL, where R is the radius and L is the slant height. So this is CSA. Now we will write TSA. TSA is CSA plus area of this circular surface. Area of the circular surface is pi r square. Area of a circle is pi r square. So pi RL plus pi r square. In this, pi r is common, into L plus R or R plus L we can write. So this is TSA of a cone, square units. So CSA is pi RL and TSA is pi R into R plus L. And now we will see volume. To find volume, we have to compare one cylinder and a cone having same base area and same height. So if you consider one cylinder and a cone having same height and the same base area. Now we have to fill this cone. Suppose if we are taking sand in this cone and we are filling it into the cylinder. We have to fill the cone 3 times, then only the cylinder will be completely filled. That is, volume of the cylinder will be 3 times the volume of the cone, or volume of the cone will be 1/3 of the volume of the cylinder. So already we learned what is the volume of a cylinder. Volume of a cylinder is pi r square h. Pi r square h. So as I told you, volume of the cone will be 1/3 of the volume of a cylinder. So it is 1/3 pi r square h. So it is very easy to remember the volume of a cylinder and a cone. Cylinder will be pi r square h because area of the base is circle pi r square into height. So cone area volume will be 1/3 pi r square h. So CSA is pi RL, TSA is pi R into R plus L, and volume is 1/3 pi r square h cubic units. Next is about sphere. See, there is a lemon in the shape of a sphere. The surface area for a sphere, there is only one surface, that is circular surface, only one surface. So surface area, there is only one surface area. Surface area of a sphere. Surface area of a sphere is 4 pi r square. 4 pi r square. So surface, there is only one surface for a sphere and the surface area is 4 pi r square, the formula. See, if I cut this lemon into 2 pieces, we will get each one is in the shape of a hemisphere. So now we will see hemisphere. So hemisphere has 2 surfaces. One is one flat circular surface and one curved surface. So now if surface area of a sphere is 4 pi r square, what will be the surface area of this part? Only half of that. So it will be 2 pi r square. So CSA of a hemisphere is 2 pi r square. And TSA of a hemisphere is, we have curved surface 2 pi r square and we have a flat surface here. That surface area, you know, it is circular in shape. Area of this part is pi r square. So 2 pi r square plus pi r square, it is 3 pi r square. So CSA of a hemisphere is 2 pi r square. Total surface area is 2 pi r square plus pi r square, it is 3 pi r square. If you wanted to check this, how we are getting this? See here, this is a hemisphere. You can insert a pin or nail something inside and you can wind a thread around it, completely covering the surface, this surface. You have to cover it and we have to see the length of the thread. After that, remove the thread. You have to take the same complete sphere you have to take. Keep a nail on the top. Then completely wind a thread completely for this lemon and measure the length of the thread. You will see that what is the length where you are getting for this part. And when we measure the length of the whole lemon, it will be 4 times that of this part. So you know that this is pi r square. So pi r square into 4 times, it will become 4 pi r square. So surface area of a sphere is 4 pi r square. When it becomes a hemisphere, half of that 2 pi r square. But total surface area comes for a hemisphere. There is one flat surface, circular surface, pi r square plus 2 pi r square. We will get 3 pi r square. And volume of a sphere is 4 by 3 pi r cube. Pi r cube. If volume of a sphere is 4 by 3 pi r cube, volume of a hemisphere is half of that. That is 2 by 3 pi r cube. So there is only one surface for a sphere. That area is 4 pi r square. Volume is 4 by 3 pi r cube. Hemisphere has one curved surface. So surface area is 2 pi r square. Total surface area, curved surface area plus area of the circular surface, 3 pi r square. Volume is 2 by 3 pi r cube. That's all about the formulas. Now we will move on to the exercise. Exercise 15.1. First question. Two cubes each of volume 64 centimeter cube are joined end to end. Find the surface area of the resulting cuboid. Two cubes each of volume 64 centimeter cube are joined end to end. So here there are two cubes. Here one cube and here one cube. They are joined together. Side by side we kept together. So each has a volume of 64 centimeter cube. So volume of each cube is 64 centimeter cube. We'll write volume of a cube. Volume of the cube or each cube is 64 centimeter cube because volume is, unit is cubic centimeter or centimeter cube we can write. Find the surface area of the resulting cuboid. See, when we kept two cubes side by side, it forms a cuboid. We wanted to find the surface area of this cuboid we should find out. So, volume of the cube is 64 centimeter cube. We know that volume of a cube is a cube. A cube is equal to 64. A is equal to cube root of 64. What is cube root of 64? It is 4. Cube root of 64 we can find by 4 into 4 into 4. It is 64. So, cube root means from 3 similar number, one number we will take it out. So, it is 4 centimeter. Otherwise, we have to factorize 64 and we have to find out. So, A is 4. That is, side of this or edge of the cube is 4 centimeter. All the sides of these cubes are 4 centimeter. Here 4, breadth also 4, height also 4. Now, we want to find the surface area of this cuboid. Now, when it becomes a cuboid, what is the length of the cuboid? Length of the cuboid. So, when we kept two cubes side by side of having side 4 centimeter or edge 4 centimeter, what is the length of the cuboid? It becomes 4 plus 4, 8 centimeter is the length. What about the breadth of the cuboid? Is there any changes for the breadth? There is no change for the breadth. Even height. Side by side we are keeping the cuboid. So, height also will remain same. Breadth is same. Only length will change. So, breadth is 4 centimeter. Even height also 4 centimeter. We want to find the surface area of the cuboid, resulting cuboid. So, we want to find the total surface area of the cuboid. If it is curved surface area, especially they will say CSA. So, we will find the surface area, total surface area of a cuboid is 2 into LB plus BH plus LH. Remember all the formulas. 2 into L, 8, B4 plus again 4 into 4 plus again 8 into 4 is equal to 2 into 8 4s are 32 plus 16 plus 32. So, we will add all these 2 into 32 plus 32, 64 plus 16. You will get 80 is equal to 160 centimeter square is the surface area of the resulting cuboid. Second question. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. So here, top of a hollow hemisphere, there is a hollow cylinder. So first we will draw the cylindrical part. And then below that we have to draw the hemisphere. So this hollow cylinder means both the sides will be open. So here is the cylinder base. Now here there is a hemisphere. So like this. So this is the shape of the vessel. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. This is the cylindrical part and this is the hemispherical part. The diameter of the hemisphere is 14 cm. So here when it is attached, so you are learning about the combination of solids. You will not get a separate cylinder sum or a hemispherical sum. You will get always combination of solids, that is cylinder joined with hemisphere. Maybe sometimes both the sides will be joined with hemisphere or cone, something like that. So here both are attached together. Always diameter or radius of the cylinder and the hemisphere will be same, equal. So here they told that the diameter of the hemisphere is 14 cm. Diameter of the hemisphere and diameter of the cylinder will be same. So diameter of the hemisphere is equal to diameter of the cylinder. That is 14 cm. Therefore, radius of the hemisphere is 14 by 2, 7 cm. You know half of diameter is radius. Radius of the hemisphere is 7 cm. Same way radius of the cylinder is also 7 cm. Cylinder is also 7 cm. So in combination of solids, as they are joined together, diameter and radius will be always, most of the time it will be same. And the total height of the vessel is 13 cm. Total height of the vessel is 13 cm. So total height of the vessel is 13 cm. Now look here. If from here to this side, if this is the diameter, we know that from here to here it is the radius from the center. If as it is a hemisphere, this is also will be radius. When this is a complete sphere, when you cut it into two parts, see this is the diameter, even this is the diameter. So when you remove the half part, top part, see what is this? This is the radius. This is the radius. So radius of the hemisphere and even cylinder is 7 cm means this is also 7 cm. This perpendicular height also 7 cm. So total height of this vessel is 13 cm and the radius of this hemispherical part is 7 cm. Then what is the height of the cylinder? Therefore, height of the cylinder equals cylindrical part equals total height 13 minus this radius we will subtract. 13 minus 7, it is 6 cm. So we have to first write all the correct values according to the question. Then we will do the sum. So now we got radius of the hemisphere is 7. Radius of the cylinder is 7. Height of the hemispherical part, there is no height for hemisphere. Height of the cylindrical part is 6 cm we got. Now we want to find the inner surface area of the vessel. So surface area of the vessel, inner surface area of the vessel equals so here when we find the inner surface area, this part is joined together. So that area we don't want to find out. And it is a hollow cylinder told. So this part is open. That area also we don't want to consider. So inner surface area inside, what is the area of this vessel means curved surface area of the cylinder plus curved surface area of the hemisphere we have to consider. So as these two ends are joined together, that part we won't consider. That is one single vessel. So curved surface area of this cylindrical part and the curved surface area of the hemispherical part we will consider. So we will write CSA of the cylinder plus CSA of the hemisphere. So CSA of a cylinder, we know the formula is 2 pi RH, and CSA of a hemisphere, the formula is 2 pi r square. After writing this, we will take common because we know that radius both the case it is same. So we will take whatever maximum Common letters, will take it common out. So calculation will be less for you. So 2 is common, 5 is common, 1 R is also common. The remaining letter here H and here 1 R is remaining. Now we will substitute. After writing all these, now we are going to substitute the value. So here they told we have to take pi as 22 by 7. So 2 into 22 by 7 into radius. Both the radius are same. So here it is 7 is the radius. Height means height of the cylinder. That should be careful. It is 6 centimeter. 6 plus radius again it is 7. So here 7 and 7 will cancel. 2 into 22 is 44. 44 into 13. We have to multiply and write. So 44 into 13. It is 572. So 572 centimeter square is the inner surface area of this vessel. That's all for today. Thank you.